Okay, good afternoon, one and all. Very less students get admitted. Again, we will wait. See, who is Mahesh Patil? Mr. Mahesh Patil, please, you change your name with your roll number. Mahesh Patil. Okay, only 14 students are get admitted. What about others? Please respond me. Anyone in the group out of 15 members? Am I audible to all of you, please?
Yes, sir.
Okay. Only 20 students are present out of 139. So, okay, because immediately after the one of the big festival, that is Deepavali, so still someone are in the mode of eating some next kind of sweets from the festival, right? So suddenly they will not charge. It takes time to everyone. This first class after Diwali. Okay, again 2 or 3 minutes I will wait because only 27 students are present here. Just for remaining 110 friends want to join again. Okay, at 12:20 I will start my lecture. Please, all of you make mute. Someone voice is coming here. Please make mute all of you. It's my request. See, please, I request you all with your close friends, with your close classmates or neighbors, please you insist them to join the class, join the lecture. Only 50 students are present out of 139. Please, you call them or you make a message, you text it, and you enable them to join the lectures. Okay, fine. Now it's 12:20. Already I waited 5 minutes. Okay. So only 60 students are present over here. Maybe other students, maybe they are busy with festival still. What I thought so. Okay, someone they went to their uh, relatives' home, relatives' village, or some other places. They may still not settle to the attend classes. So okay, anyhow, dear all students. So I will share my screen. Yes, fine. I admitted to everyone. Okay, dear all students. Last class we taught this J conditions, that is conditional jump. So first of all, again, after long back means after 1 week, I welcome you all for the microprocessor lecture again after Diwali. It's the first lecture. So welcome you all again for my microprocessor lecture. So here in the last class, we discussed some instructions of microprocessor from the unit number third, and we also taught first program how to execute. Because of shortage of time, last two lectures, someone may not get how to execute the lab programs in the TOSM software. So don't worry who are not getting today also. I will repeat the same things for lab session. Before that, first 1 hour, I will take theory for instructions from the unit number 3. After 1 hour, we will go for lab sessions. Okay. So, dear all students, uh, is it, am I audible and my screen is visible to everyone? Please respond me.
Yes, sir.
Yes, sir. Audio
Okay.
and visible.
Thank you. Thank you. So, dear all students, I didn't got any questions after whatever I had class last Monday at the date of 2nd November. So after that, I didn't got any questions. So now what I will do? अभी मेरे पास कोई भी questions नहीं आया किसी बच्चों से भी. I think everyone is understand very well. So again, today directly I will start with the instructions where I stopped at the last lecture. Again, still you have any doubts, please text me, message me, call me, and get clarified about all the doubts. Okay. So, dear all students, in the last class, last lecture from the unit number third, we have discussed this J condition. J condition means that is conditional jump instructions we discussed. I taught with the flag, that is jump instructions flag, and this mnemonics with all the jump conditional jump related we have to taught. Okay. So dear all students, today I will start with call unconditional call. Last class we discussed conditional jump. So today onwards we will discuss unconditional call. So in that unconditional call, again near and far, there are two types are there. So this is for means we say it is a inter segment call, and one more that is intra segment call. Inter segment is near call and inter segment is for call. So these two we will study now. There is all comes under call instruction. So CALL, the mnemonic of the instruction is call, and as generally we called it as unconditional call. Unconditional means without any conditions, any terms and conditions, we have to call these instructions by using the mnemonic CALL, CALL. So this call is an instruction. Please, if any questions, ask me. Otherwise, you make mute. Okay. So in the unconditional class call instruction that transfer the program control to subroutine. Whenever you are using a branch and a subroutine in the program, that time you are using this call instruction. The call instruction is directly you have to call the subroutine or sub branches in the program. So in this the call saves that is stores address of next instruction in a stack. Everyone is based on the stack memory, that is the next instruction in the stack before branching to the subroutine. So in that subroutine, before going to be branch, make it as a branch. That time we have to use the instruction call. At the end of the subroutine, control transfer back to the main program again. For that, we have to use return address from the stack. So in this call, unconditional instruction, that unconditional call instruction, there are two types. One is near call instruction, and one more second one is for call instruction. So near call instruction we called it as intra segment call. Near call instruction we call it as intra segment. What is intra segment? Within the segment, within the same segment, we say it is the intra segment. And the second one, that is a for call, or we have to say inter segment. Inter segment means it is with outside with the segment. So first one we will look into that, that is intra segment. So अभी ये conditional call में दो types है. दो types वो बोले तो first one is that is near call है, और the second one is for call. So in the first one near call also we call it as, हम अब दूसरा name से हम बोलना चाहे तो that is intra segment call, and the second one is for call, or we have to say inter segment. So in the पहला category में, that is inter segment call में वो क्या बोल सकता है? It's a new subroutine. Call must be in the same segment. Intra segment. Intra means within the segment. Within the segment means what? That is the same segment. That's what we have to use the word same segment. That is called the subroutine within the same segment. And one more feature of this intra segment is the call address can be specified directly in the instruction or indirectly through the register. We have to directly specify this call address within the instruction directly or indirectly through the register. We have to use this memory locations. Okay. And the third main features of inter segment is uh, in that we have to execute it with a near call with some example. So the 8086 will push current IP into stack. So IP means what? That is instruction pointer. We have to push the instruction pointer into the stack. That time we have to use the call instruction, that is near call intra segment call instructions we have to use in the situation of that is instruction pointer into the stack. And the second one, to make the decrement by each step by 2. In that time you have to study it. Decrement by stack. Whenever stack is comes, you are going to decrement it. Whenever pop is comes, you are going to increment it. Pop मतलब increment होता है, stack मतलब decrement होता है. So the new value loaded into the instruction pointer to the stack, and the controls transferred to the subroutine within the same segment, because intra segment is nothing but it is a same segment. So with the one example I will explain you, that is called sub add. So subtraction or addition, this is the one of the instruction, that is operations. Either you're going to do the subtraction or you are going to do the addition in the microprocessor, but our instruction is call. What is the call? It's a mnemonics for the instruction, call. So in that whenever that stack comes, segment stack segment with the -1 and -2 totally decremented by 2 steps, that is sp -1 to the stack pointer -1 to, you have to decrement 2 times, and finally you are going to be stored in the stack pointer. So here also in the instruction pointer, the one offset address of sub add, there is a one offset address of 4 bits, you are going to be add to the instruction pointer here. So this is all about how we have to use the intra-segment call. So in the call state instruction, there are two types. First one is intra-segment call. So now we'll go to the second types. अब वो दूसरा कैटेगरी कौन सा है? वो दूसरा कैटेगरी है इंटर सेगमेंट, INTER, इन इंटर सेगमेंट. इंटर सेगमेंट मीन्स वो क्या होता है? Outside the segment. So the new subroutine called is in the another segment. Another segment, or we have to say outside the segment. Here is the code segment and the instruction pointer both get new values. So whenever you are going to use the another segment or a separate segment, that time the code segment and the instruction pointer are get to be new values. And also the call address can be specified either directly or through register or memory locations as like in the previous one. So here the some following executed for call with the inter segment, that is push code segment into the stack. Push, you have to push the code segment into the stack. Why you are going to push it? Because it is a another segment, inter segment. Two segments are different. That's what you are going to be push the code segment into the stack, and you are going to be decrement stack pointer by 2, or you have to push the instruction pointer into the stack and decremented stack pointer by 2. So load the code segment with a new segment address and load the instruction pointer with the new offset address. Whenever instruction pointer comes, it is an offset. Whenever code segments, the stack segment, data segments are comes, that is a segment address. And also you are going to control transfer to the subroutine into the new segment. That is the main functionality of inter segment or for call, FAR, for call. For example, here again stack pointer -1, stack pointer -2. Suddenly by those two times you are going to be decremented. That's what stack pointer -2. Again, that final result is going to be stored in the stack pointer. So here also say that is instruction pointer, because of it is an offset address, you are going to be decrement by 2. So CS means what? That is a code segment, and IP means instruction pointer. Both are with the new segment address of subtraction and addition instruction, and also new offset of subtraction and addition for the instruction pointer. So there are two types, that is call conditional or unconditional call, or simply you say it is a call. That is the third category. So now we will move to the next one, return statement, fourth category. So in that fourth category, so already previous we have to study it, 10 instructions plus 7 instructions plus 20 instructions. After that, this call instruction, unconditional call is 2 instruction, that is far and near. So after that, I will move to the one special instruction, that is RET. So RET in the sense what? That is the return instruction. It is nothing but a रिटर्न इंस्ट्रक्शन. सी अभी हम लोग सी प्रोग्रामिंग में रिटर्न स्टेटमेंट हम यूज करते, रिटर्न जीरो बोलते, रिटर्न एनी ऑफ द वेरिएबल्स नेम बोलते, इट इज गोइंग टू बी रिटर्न ऑन द आउटपुट कंसोल, RETURN, return, one word we have to use in the C programming. Same way for the return statement, we have to use it in the microprocessor, that RET in the sense what? It is a return instruction. So this return instruction, what it will do? It will instructly causes the control to the return to the main program for subroutine. So whatever the data you are going to be print on the output screen called by the subroutine, those statements or those value, those data, this statement is going to be displayed on the output screen. That's what we have to use, return, RET, return instruction. What it will do? Control to the return to the main program from the subroutine. Only single sentence, single line, that is enough for the return statement in the microprocessor, same as what we are going to use return statement in the C programming. Okay. So after that, in that return statement, again here also two types. One is intra-segment return, and another one is inter-segment. Intra-segment means again within the segment. Intra-segment, inter-segment means again outside the segment. So within the segment, if you are going to do the return statement within the segment with the IP or stack pointer, instruction pointer or stack pointer, that is going to be make it as a +2, which is a pop operation. That is intra segment with pop operation. That is a stack segment with the SP +1 and stack segment with the SP +1 second step. So 1 + 1, that is 2. So totally stack +2 with the stack pointer. Same way, if you are going to return n number of statements, that time stack pointer +2 plus n number of statements it is going to be specifies for the intra-segment return statements. So next one, inter-segment return statement. It is a also same. So here in that instruction pointer with the stack pointer, that is the stack pointer and stack pointer +1. So here the stack pointer totally 2 times you are going to be increment, that is SP +2 stack segment, and finally that data is going to be stored in the code segment here. So that is inter segment. Inter segment means from the outside, stack pointer +2 and stack pointer +3 and so on, stack pointer +4, stack pointer +5, so on. You are going to be used n number of stacks into the return statements. So that is intra-segment return statements. So here in the RET, again two types, that is intra-segment return and inter-segment return statements. Okay. So these all one instruction, please all of you make a note, you make a list out, you will get clarified while studying it more clear to you students. So the next, this is all about conditional and unconditional call and return statements. So today what we discussed, inter-segment return, intra-segment return, conditional call, in that inter-segment for call, in inter-segment for call and inter-segment for call. Just these are, you go through these instructions, what is the functionality and what it will do. That is with the stack pointer and the uh, stack segments. Okay, with the instruction pointer. So I think I cleared today's these 4 instructions: RET with the inter-segment and with inter-segment. Same way call with the intra-segment and with inter-segment. 4 instructions what I covered today. अभी हम इतना होने के बाद और थोड़ा instructions आता है. वो instructions we called it as processor control or machine control instructions. Now onwards we will discuss processor control or machine control instructions. So this push F you studied, that is push with the flag, pop with the flag you studied, and LEH we are going to be studied, that is shift, arithmetic right shift. All those we will study now one by one. So here after that we will go through this processor control or machine control instructions. So dear all students, make a note, uh, separate heading today's onwards, separate heading with the instruction. Those are nothing but processor control instructions or machine control instructions. Please know, make a note of this. This is the heading of today's instructions: processor control instructions and machine control instructions. So as per your syllabus, that is Okay, the unit number 2. Okay, all are comes under year 0, year 6 instruction set only. So today's we will move to machine instructions, or we have to say processor control instructions or machine control instructions. So in that process control instructions and machine control instructions, some different categories. First one is that is STC. STC means what? It is set the carry flag. ST means what? Set. The C means carry flag. Second one is CLC. Clear the carry flag. CLC means clear the carry flag. STC means set the carry flag. And CMC means CM means complements the carry flag. CM in the sense complements, and C in the sense carry flag. Complements the carry flag. Three different carry flags are there. So that is STC, this first one, STC, and CLC. CLC means clears the carry flag. STC means set the carry flag. And CMC. CMC means complement the carry flag. See, please, I request you make a mute. If anyone going to be do like this, all are get disturbances. So it's my request, all of you make mute better. So here, first three carry flags in a group: push up, pop F, LA, HF, SHF, STC, CLC, CLD, STD, CMC, STI, CLI. These are the instructions of list of instructions for processor control, or we have to say machine control instructions. So out of this, we have to again make a subcategory. उसमें अभी सब कैटेगरी में क्या क्या है? Carry flag. First category is for the carry flag. In that, again, three types are there. STC, set the carry flag. So already you studied different 9 different types of flags, right? Those in unit number 2, totally 9 different flags. In that, one flag you studied, that is the carry flag. So to set the carry flag, we have to use a one instruction, that is nothing but STC, set carry flag. And one more with the carry flag, we have to use the instruction CLC. CLC in the sense what? It is a clear the carry flag. And the third one is CMC. It is used for to complement the carry flag, or no other flags are to be affected. So complement the carry flag, clear the carry flag, and set the carry flag. These three are types of carry flags. We have to use these instructions in the microprocessor for different operations. So next one comes interrupt enable flags. So one more flags we have to study it, that is interrupt enable flag. So in that interrupt enable flag, you are going to be use STI and CLI. So these two, STI and CLI. STI is used for to set the interrupt enable flag. ST is in the sense what again? To set, I in the sense interrupt. To this instruction is used to set the interrupt enable flag with the no other flags are going to be affected. So बिना other flags को बिना affect करने से set interrupt STI interrupt flags. Okay, same way we have to use one more, that is CLI. It means that what? CL in the sense what? Clear. Here also you have to study it in previous. So CL in the sense clear, I in the sense interrupt. This instruction is used to clear the interrupt enable with not affecting any other flags in the microprocessor. So in the interrupt, again two types: STI, set the interrupt flag, and CLI, clear the interrupt flags. So again in this third category of machine instruction, that is for direction flag. In that direction flag, so here that is STD, and CLD. So these two again. So STI, CLI is over, STC, CLC, and CMC is over. Now I am explaining these two, that is STD and CLD. So here D in the sense what? That is a direction flag. ST means set. So this instruction is sets the direction flag without affecting any other flags. And also CLD means what? That is clears the direction flag. To clears the direction flag without get affecting to any other flag. That is again two types in the direction flag. So next one, fourth one is a TF. What is TF? TF in the sense what? It is a trap flag. So for that, what purpose you are using a trap? For step by step or no step execution purpose. One step, single step or no step execution purpose. We are using this TF flag. So in the machine instructions, first one you have to study the carry flag. Second one you have to study interrupt enable flag. And next one you are going to be studied trap flag. So here also you have to use to set the trap STF. That is along with that push and pop, you have to use this trap flag. What is a trap? So here I will show you this. See, in this is the notes of unit number 2. So in that you have to study it. So this trap flag, what is main function of this trap flag? That is one, perform a single stepping or no stepping purpose. Carry flag I have to explain, and this is the direction flag I have to explain. Now I am going to the trap flag. In the unit number 3, trap flag you have to use it along with the push up. Already you studied this push up instruction, pop instructions you studied, and BH. It's a all you still didn't study. In the logical instructions I have to explain. So all is used with the BH. B means is the name of the register with a higher nibble. That is a 01 hexadecimal value. You are going to be all with the BH value or BX value, BL value. Okay. So here this trap flag for the single step, for the single step or for no step. That time you are going to be used this TF with the push and pop operations. Push F, pop BX means what? Base register, and that is B register with the higher nibble with the 01 value. Again you are going to be push BX. Again you are going to the pop F. So these instructions already you studied. That trap flag you are going to be used with these things. So that is set TF. And in that again one more type, reset. Reset means what? Whatever you are going to be set, again you have to do the reset. That is to come to the initial condition. That time you are using reset tab again with the push up, pop, and that B register. Any register, either A, B, C, D, any register you have to take for your example. In my example, I am taking B register with the push and pop operation. You have to use the trap flag. Why we are going to be use push and pop operation means either going to be decrement or it's going to be increment. Increment in the pop and decrement in the stack. For that, either we are going to be in a single step we are decrement, or in a two step we are decrement, or in a multi step we are decrement, or in a no step we are decrement. For that, we are using a trap flags. Okay, so this is all about trap flag, direction flag, and carry flag. So next one, I will move to the next one. That is iteration control instructions. So iteration in the sense what? All of you aware of that iteration. The meaning of iteration is nothing but looping within the cycle. Continuously within the cycle, the data is going to be executed until and unless it will reach the end point condition. Up to reach endpoint condition, that data is going to be executed within the loop full. That one we have to say iteration. So now we will go through the iteration control instructions. So in this iteration control instructions, these are the instruction cause a serious instruction to be executed repeatedly. Because of repeatedly means in a going to be loop full of a cycle that is going to be executed. So we call it as a repeatedly executed and the number of instructions is loaded in the C register. CX means what? It is 16-bit. Either it may be higher nibble or lower nibble register. And the CX is decremented by 1 after every iteration. So either it is going to be decrement or increment after each one cycle. Every iteration, that iteration occurs until it will reach the end condition. So here we have to say up to each last condition means zeroth iteration. Last iteration to up to to reach last iteration, it is going to be executed. And the maximum difference between the address of the instruction and the address of the jump can be 127. So 2 raised to 8 in the sense what? It is a 127 is going to be reached. Okay. So again, in that iteration control statements, there are different kind of again different categories. First one is the loop label. First one is loop. So in that loop again, loop on equal or loop on 0, and the third one is loop on not equal and loop on not 0 conditions. So again, these three different iterations instructions are there. So first instruction I am calling that loop label. So in this loop label, in what it will do, it will jump to the specified label of C register with a 16-bit is not equal to the 0, is not equal to the 0, and decrement C register by 1. So decrement the C register by 1 because it is not equal to 0. That one iteration is going to be happen. That is a loop label. How? With the one example, move instructions, all of you aware, CX04H. What is this meaning? As already we studied, 04 hexadecimal value going to be transferred into the C register by the help of move instruction. अभी ये चार नंबर है, वो चार नंबर हेक्साडेसिमल के चार नंबर वैल्यू और इंफॉर्मेशन और डेटा हमें क्या करेंगे इधर? That is transported into a C register. So by the help of move instruction. Again, in the next one more A register we have to take and B register we have to take. So here whatever the value is containing in the B register, that is transferred it into the A register with the help of B. So here I have to use the back one coming back to the loop. So here I have to use the back, and here also I have to use the back. So this one I make it as a loop, back to back, entire this portion, back to back. So I have to make it as a loop until and unless that all the iteration is going to be reached. Every cycle is going to be reached up to reach end condition. So here we have to use the back to back. This is the loop label. Instead of back also you have to use loop, no problem. Anyone you are going to be use it. Okay. So this is the normal loop. So in another loop, second loop, that is with the equal loop or 0. Loop one equal or loop one 0. We have to say loop one equal or loop one 0. Here also we have to use a looping statement. Either it may be equal or it may be 0. First one is normal, either not equal and not 0. Second one is with the equal and with the 0. That is a second condition. Here also we have to use back to back or loop to loop until and how you are going to be used in the C programming. Also some looping concept, same way you have to use the looping concept in the microprocessor, but that is going to be specified with loop equal, loop on 0 or loop on equal. So in third category, that is a loop on not equal, NE in the sense what? On not equal, and loop on not 0. Loop on not equal and loop on not 0. So here also it is same as the above, except that is a with opposite. So it is a with equal and 0, but it is with the not equal and not 0. Same looping conditions you have to use it here. It's the equal and 0 condition. Okay. So this is the iteration instructions. Totally 3 iteration instructions are there. These are loop label, loop on equal or loop on 0, and the third one is loop on not equal and loop on not 0. This is the condition we have to use that iteration instructions. Iteration instructions. So next one, again some more instructions are there. Those are shift and rotate instructions. So next to the main again subheading, that is, please all of you make a note. This is again one subheading. Explain shift and rotate instructions. Don't worry, after this completion of this unit, I will make you a all the list of instructions, and I will forward to you. Mainly 50 to 60 instructions. As already I said, I will forward you with a single list. Okay, so now all of you take next heading, that is explain shift and rotate instructions. So shift and rotate also you studied in the C programming, also you studied in the data structure, how you are going to be shift and how you are going to be rotating. Okay, so here there are four shift instructions are there. Those are SHL, SEAL, SHR, SEAR, and four rotate instructions are there: ROL, ROR, RCL, RCR. So four shift register as well as four rotate instructions are there. Those we call it as shift and rotate instructions. For shift, four instructions, and for rotate again four instructions. So totally 8 instructions you are going to be studying in the shift and rotate instruction. So out of all these 8, one by one, now we will study those. So first one I will take shift instructions. So in the shift instructions, that is SHL is there. SHL in the sense what? Shift left. SH indicates shift and L indicates left. Shift left. And the second one, SAL. It means S means shift arithmetic left. A in the sense arithmetic, L in the sense left. Shift arithmetic left. First one is just normal shift left. Second one is shift arithmetic left. And the third one, that is SHR, as like in the first one, shift right. This is shift right. And the last one in the shift instruction, SAR. SAR in the sense what? Shift arithmetic right. Shift arithmetic right. So there are totally 4 shift register: shift left and shift arithmetic left, shift right, shift arithmetic right instructions. So now first one we will move to that shift instructions. In that I will take first one as a SAL or SHL. That is the format is this one. Either you are going to be use SAL or SHL. So shift, this is the shift arithmetic left. So you are while you are going to be shift, always you have to use destination and count. So destination means what? Wherever the data is going to be shifted, that one destination point is need. That's what I have to use here, destination. And how many times you are going to be shipped, how many times you are going to be shipped, particularly for that I have to use the count. Count is for what? How many times we are going to be shipped, either it may be right or left. Okay, so as per this SAL instruction, that is shift arithmetic left, and SHL means shift left, normal shift left. So here in that left shifts, you are going to be shift the left to the bits of destination, and the most significant bits shifted into the carry, and the least significant bits is shifted or gets filled by the zero value. Same thing what you have to study in C programming and data structure, same thing here also you have to use it. Whatever you have to shift and previous bit is going to be filled by zero value, that is shift left and by filled with the zero value. So here an arithmetic shift means what? Whenever you are going to be shift with the left, and if carry is comes, that carry is added into the filling that filling bits. Okay. So this is the MSB and LSB. So here the bits are shifted count number of times. How many count number means what? How many times you are going to be shifted? If the count is one, then directly specify it in this instruction by shifting by one. If count is greater than one, that time what you have to do? It has to be given using a CL register. C is the register, L is the lower nibble. That is 8-bit CL register, and also the destination with the register and memory location. Wherever you are going to be using destination in the microprocessor, either you have to use a memory or you have to use a register for storage some value to that particular location. Okay. So for example, SAL BL1. So this one is going to be shifted with the arithmetic. SAL in the sense what? Arithmetic. That is shift left, shift left. That BL register bits once. One time you are going to be shift. That is the count is what? One. One time you are going to shift that BL containing a information or a data. Consider here the BL may be, for example, BL may be 0011. After you are going to be shifting one times, that 11 is comes to the left side, is going to be shifted left. So here if the carry flag is comes, so what it will do? This is the one value, that is 00111100. So same value I have to show it in the blocks, that is 00001111, again 111, that is 11. So 11 again 00, this value is going to be shifted. So here what it will do, here the carry flag is going to be shifts, it is going to be shifts, and that carry flag is comes, that carry flag is operation with the BL operation. So here that carry flag is no carry flag, so that's what it will shift. This is comes to this point and this is come to this point. Same way each and every bits is going to be shifted one with each iteration, one with each iteration. So for example, move CL05H, load the number 5 in the CL register, and that is SCAL. So here you have to use the instruction SCAL. What is that meaning? SCAL, shift arithmetic left. That CL register you have to shift arithmetic left and finally store it into BL register. That is left shift BL with the CL of 5, and that number is going to be times. How many times is going to be specified with the count. So that is shift arithmetic left and shift normal left. So next one is shift with right and shift arithmetic with right. So here in the shift normal shift right, that is same way left, you have to consider it into right side. So in the SCL or SHL, you are going to be shifted all the bits towards the left side, and in the SHR same thing in the opposite direction, you are going to be shift towards the right side. Everything is same with the LSB and MSB. That is right shifts to the bits of destination, and that most significant bits gets to 0, and that all remaining bits are in each iteration is going to be shifted right, and that bits are shifted count number of times. If the count is equal to 1, it is directly specified in the instructions. Otherwise, if the count is more than 1, then that time you are going to be follow the loop and iteration for shifting the right side to each bit. So in that again same way. So in the left shift, you have to show the directions right to left. Here I am showing the direction right, left to right for the right shift. So same way in the arithmetic operations, you have to use the destination and count with the carry. Whenever the arithmetic operations comes with the carry, that is right shifts the bits to the destination, and the most significant is the MSB itself, which is going to be shifted to the right side, and the bits are shifted count number of times. So how many counts you are going to be used in this here. So here in the example, SARBL comma 1. The meaning is that shift arithmetic rotate. SAR means shift arithmetic rotate whatever the BL register is containing one time. So right shift BL bits once. Right shift BL bits once. So here, for example, this is the one condition that is going to be take a zero fill with the one time is going to be shifted. That result is, so one is come to right side this one and this is move. So this one is comes at this position and this one is comes here and these two zeros up to this and again these two ones are comes here, these two ones and these two zeros, these two zeros. So this zero is going to be added at the MSB. Okay, so this is the right shift, shift arithmetic right. These are four instructions: SAR, shift arithmetic right, and SHR, shift right, and SHL, shift left, SAL, shift arithmetic left. These four are shift instructions. All these four are shift instructions. So next, now I will move to the rotate instruction. That is rotate instruction. What are the again four categories of rotate instruction में भी अभी फोर कैटेगरी है. फोर कैटेगरी कौन सा है? ROL rotate left, ROR rotate right, and RCL rotate left with carry, and RCR rotate right with carry. Same way how you are going to be shifted, this one you are going to be use the rotate. That rotate in the sense what? The LSB bit is going to be comes into the MSB bit. Either it may be a right rotate or it may be a left rotate, and either it may be a right rotate with the carry and left rotate with the carry. Okay. So here now I will move to the rotate instruction. In that rotate instruction, first one ROL. Same way with the destination and count to we shall see how to take for the rotation purpose. So the left shift with the bits of destination and the most significant bit shifted into the carry. Here directly how to use the carry, and also MSB goes to the LSB bits, and it is shifted count number of times. If count is 1, directly specified in the instruction. If count is more than 1, that time you are going to be loaded into the particular specified register. It may be a B register, C register, or D register. Okay, so again, the destination register is going to be used for the memory locations. So here, see, this loop is creating here. In the rotate instruction, I have to create a loop. From this point to this point, there is a one loop is happening. But in the shift instruction, there is no any loop. Please make it differentiate and more concentrate on this. Please, you have to remember in that it is showing a loop. That is rotate instructions. Rotate instructions from D0 to D7, 8 bits with a carry flag. So if you are going to be rotate right to left, then it is a left rotate. Rotate left. If you are going to be move in the opposite direction like this, left to right, then it's you say it is a right rotate. Right rotate. And this is the carry flag one. Carry flag you are going to be using. So if you are going to be, if you don't rotate the carry flag, then normally you have to say right rotate and left rotate. If you are with the carry flag, you are rotating right rotate with the carry flag and left rotate with the carry flag. So RCL in the sense what? Right rotate with the sorry, L means left rotate with the carry flag. That is rotate carry flag left. So again here it is a rotate carry flag with right. R in the sense right. So RCR, that is a destination count with the rotate carry right. So only the very simple concept shift and rotate instructions. In the shift there is no loophole is comes, but in the rotate loophole is comes. As per the loopholes you are going to be rotated, and in that rotate two times either with the carry flag or without the carry flag. Right with carry flag and right without carry flag, and also right left with carry flag and left without carry flag. So these are the instructions used for shift and rotate instructions. So dear all students, please count today how many instructions I have to cover. Uh, so here, that is RCR one instruction. So in the shift and rotate instruction, there are 4 plus 4. Today's 4 plus 4, 8 instructions in the shift and rotate instructions. And here 3 instructions, that is loop on not equal, loop on equal, and normal loop. Again 3 instructions. 8 plus 3, 11 instructions. So and again here TF with reset and set, two instructions here. 11 plus 2, 13 instructions. And also here for the directions again 2, 13 plus 2, 15 instruction. Here in the interrupt again we have to study 2 instructions. 15 plus 2, 17 instruction. And here in that we have to use it in the carry flag again 3 instruction. 17 plus 3 is 20 instruction. We have to study it. Along with that, we have to study it. That is return instruction 1, intersegment and intersegment. Again, here it is 2, 20 plus 2, 22. And here again for the call instruction 2 call instruction, intersegment call and intra-segment call. So totally today I am explaining you 24 instructions. Very simple 24 instructions I explained today. So I think it is more than enough for today's lecture, because very less number of instructions we are going to be studying, because for the remembering purpose it may take time. Okay, so for the lecturing, today's lecturing, I'll give 24 instructions, very easy. So these all are almost one is same as another one. So by name of the instruction itself is says its explanation, right? So dear all students, all these 24 instructions uh, we have to study today. So what you will do, you go and make a list out, go and make a list out today's whatever I explained, all 24 instructions, and just you remember that particular instruction functionality. What is the functionality of particular instructions? Okay, so make a list out and study in such a way that almost all the instructions you have to remember very easily. Okay, so dear all students, this much is enough for the today's lecture. Please, any questions, ask. We have to discuss now for 5 minutes. If any queries are there, please ask me. Otherwise, after this 5 minutes, I'll go to lab session. So one program, whatever is pending at the last lecture, that one program I will show how to execute it. So please, before going to the lab session, any doubts or any not understood concept is there, any instructions you are getting difficult to understand about the today's out of 24 instructions, please, we will discuss now within 5 minutes. Yeah, please make this, go through these notes out of this 24 instructions, recall it within 5 minutes. Take a 5 minute time and you go through these notes. When any doubts or comes, please raise your voice. Okay, I'll give you 5 minutes. Don't leave the meeting. Again, I will start lab session for 1 hour. At 2:15, my lecture is ends. Okay, up to one more hour, I have to conduct lab session. Only you take a 5 minute time to go scan these notes, any notes. Okay, students, no doubt here. It means that now we will go to lab session. Students, 97 students are
Yes,
present.
sir.
Okay, fine. Dear all students, all of you installed TASM software, whatever I shared that exe file to everyone, or still anyone is facing a problem in